Welcome to Castor, the next generation IDE that keeps your requirements, design, and code all in sync. Every Castor project starts off with requirements. A validation schema describes the form of these requirements written in natural language. In this example, we have a train management system with 3 use cases. Each use case has actors, goals, purposes, preconditions, postconditions, and triggers. When clicking the Analyze Requirements button, all of the domain concepts and the relationships between them are extracted. As you can see within our symbol table here, we have each use case, each entity, and each property for all of my domain concepts. This is used to construct my domain model and a sequence diagram for each use case. If I'm happy with my design, I could choose to promote my domain model and my sequence diagram, which will construct my class diagrams and my boilerplate code based on the framework I decide. Here I chose Nest.js. We also support Fast API. When clicking Promote, all of my domain concepts are transformed into class concepts. As you can see, now I have my ERD diagram, my class diagram for each one of my domain concepts, as well as my previous sequence diagram and domain model. I also have my boilerplate code structured in the format of a Nest.js project, which holds my controllers, modules, services, as well as entities which represent my database concepts. Now that we have completed these simple steps, we have a boilerplate project that has requirements, diagrams, and code all in sync. I can now showcase different types of change propagation that could occur. In this example, I add a method to my payment service. Let's name this method handle many payments. Once I save, many sync events occur and populate the sync queue. The sync queue propagates the change from the diagram into the code. In this example, I add a new attribute to my service. Let's call it train number, or rather train ID. As you can see, once I save and the change events fire, if we go within our train service, we have our new attribute train ID. The intermediate representation cd.json is the source of truth between these 3 different types of artifacts. It's a graph that holds all nodes and edges, which represent the relationships between our diagrams, code, and requirements. I will now showcase changing a relationship between 2 different types of classes. If I delete the association between scheduling service and schedule controller and create an inheritance relationship between these 2, this will now be propagated to the code. So on save, sync events fire, and if I go and look inside my scheduling service, as you can see, we have an extension of scheduling controller. In this example, I show what it's like adding new entity relationships within our ERD. If I add a credit company entity and create a relationship between credit company and payment of 1-to-1, On save, we have a new credit company entity with a one-to-one relationship with our payment entity. Now, showcasing how requirements change cascade, we have our passenger symbol. If I want to, let's say, rename passenger to customer, and I click save, many sync events fire, which will remove all references to passenger and rename them under the new label customer. As you can see, we have our new entities, controllers, services, and modules, and within all of our diagrams, including sequence, customer is renamed. Thank you for listening.